connected to.
No, but it'll stream regardless of that. Okay.
That's funny.
Done? Alright, everything's unplugged.
That's good. Yeah, thank you.
All right, you're set to go.
And we're streaming? Are we live? Can people hear me?
Yes.
Hello, everybody online. All right, good. Everybody gather around, take your seats, and we will begin. All right, welcome to today's Tech Talk. What's in the box? A guided tour of a modern web application. My name is Erik Gross. I'm the co-founder of the Tech Academy. Here's why I thought of putting together this Tech Talk, is that because today's modern web development tools give you a ton of code right out of the gate, they make rapid application development possible. But it can be a challenge to understand what each part of your new auto-generated application does. And further, how to modify the application as you make it solve the business need that drove its creation in the first place. In other words, you save a lot of time because you get a bunch of code out of the box, but how do you navigate in this stuff that you didn't create? So we're going to look at the background of why you would even need web application frameworks, and then how to work with one of them. So what we're going to do in this Tech Talk is we're going to go over the essential principles of all web application frameworks. And then we're going to review how Microsoft's web application framework ASP.NET MVC implements those essential principles. You're going to leave with a greater understanding of how web app frameworks, I'll say that again in English, you're going to leave with a greater understanding of web app frameworks, how MVC works and how to modify it, and an approach to analyzing any pre-built framework you use in the future. Now, we're going to start really basic. This is a review of the internet and the web. And just for context, since we're going to be covering a popular tool for web development, let's review the basics. The internet is a connected network of computers around the world, along with a set of protocols to describe how to format and exchange various types of data between those computers. That should be reviewed at this point. The World Wide Web, on the other hand, is a collection of linked electronic hypertext documents that is accessed over the internet. So the internet is the machines and the protocols. The web is the collection of linked documents. Good. Now let's talk about protocols. There are many protocols in use on the internet because there's many different types of digital data people want to exchange using that in the network. We've got a network of computers around the world. People are going to use it for all kinds of different things. Health information, banking information, different files for different proprietary pieces of software, and, the web. That's a type of data we want to transfer around the internet. The primary protocol in use with the web is HTTP, Hypertext Transfer Protocol. And again, a protocol is just a formal description of how to format and exchange a specific type of data. In this case, the data is web pages. Now we need to get into client and server. And the client-server model is used in the web. It's also used in a lot of other different instances in technology. In this case, the client is the computer used by a consumer, the user, to find and view web pages. The server is a specialized computer called a web server. So you've got client and server. More important to our discussion today, there are two pieces of software used on those machines that make the web work: web browser programs and web server programs. Now let's talk about web browsers a little bit. Web browsers let users access information on the web. This is something that is not that commonly known. They can also be referred to as user agents, where a user agent is software that's acting on behalf of a user. It's an agent for the user, like a real estate agent is your agent in the real estate process. In the same way, this piece of software is the agent for or acting on behalf of the user. Another example of a user agent is an email reader program. You want to read email, you tell it what to do, it fetches the email and then presents it to you for viewing. So when we're thinking about the internet, a user uses the browser to retrieve web pages. The browser renders them on the screen, and the browser facilitates user interaction with that web page. Now, another thing that's kind of odd here, though, is that increasingly, browsers can also be used to perform computing tasks. This blurs the client-server model a little bit, because you're actually, instead of doing all of the work on the server, you can have the client do a little bit of work. And we'll touch on that a little bit. So that whole factor of the browser doing some of the computing tasks is one aspect of front-end web development. You can use your browser to do some of the work. Good, so there's a little bit of a review of web browsers. Now we're going to look at the software involved. There's web server software. While the actual machine, the computer, where web pages are stored, is called the web server, the part we're usually more concerned with in web development is the actual software installed on that machine to handle requests from client computers. That software is also called a web server, which can be confusing. The server went down. That could mean something happened with the software. It could mean the actual physical machine got turned off. You need to clarify what you're talking about. So let's look at the primary purpose of the web server software. That purpose is to store, process, and deliver web pages to client computers. It's pretty straightforward. The pages are HTML documents, and they often include items needed to properly render the HTML document on that client computer. Things like images, videos, scripts that need to run, that sort of thing. And let's look at the popular web server software in the world today. This changed over the last few years. So there's actually 3 popular web server programs in use in the world today. As of spring 2019, when we're recording this, these 3 programs are installed on around 95% of the web server computers in the world. So they pretty much corner the market. Number 1 is what's called Apache. The technical term for the piece of software is Apache HTTP Server. Everybody calls it Apache. It's from the open source company called Apache. That web server software is installed on 46% of the computers in the world that are used as web servers. It's free. There's a lot of resources to learn it. It's pretty cool. Now, this is what changed in the last few years. A web server software called Nginx, N-G-I-N-X, really exploded. It now has 39% of the market. That is, it's installed on 39% of the computers that are used as web servers. It's free. And finally, what was the number 2, but isn't anymore, Internet Information Services, IIS. This is from Microsoft. It's only got 10% of the market now. One point is that 10% of the market is in the enterprise software arena. Huge companies, they pay lots of money. IIS isn't going to go away. But you can see what happened in the last few years. IIS was about 35% of the market, and it dropped down to 10. IIS comes with the Windows operating system, which is not free. You pay for Windows. You better pay for Windows or they'll come after you. Okay, so by the way, this is totally true. You're going to see later on that right on this computer that I'm showing you this PowerPoint presentation on, I have Internet Information Services already pre-installed, and you can use it. So there we go. Those are the 3 web server software programs that are out there. Now we're going to get a little more mechanical into how the web works. We're going to look at the Hypertext Transfer Protocol and how it does what are called requests and responses. That web server software that's on that server is there to facilitate this protocol, this formal agreement on how to format and exchange specific data. And the way this works is basically a request-response system. You can see the user agent, also called the browser, like Chrome or whatever, sends a request over the internet to the web server. That web server responds to the request, eventually assembling the actual requested HTML document, and then that web server sends that document back to the user agent, the browser, as a response. At that point, the user agent, the browser, can actually take that response and render it, use it to figure out what's supposed to go on the screen. So that's how this system works. One point is that both the request and the response have to be precisely formatted in accordance with the Hypertext Transfer Protocol. That's what a protocol is for. It says this is the exact way to ask for a thing. This is the exact format you're going to get it back in. So very often that request and response are referred to as the HTTP request and the HTTP response, just for clarification. Now let's talk about web resources. A resource is, let me fix this. You do it right on the screen, make this live. You're going to love this. It's a highly technical term coming in here. Thing. Web resources. Any identifiable thing that is needed for this system to work can be referred to as a web resource. So what do we mean? Well, things that can be identified are specific HTML documents, specific images, specific videos, and this is where we're going to have fun today, programs or parts of a program that can produce a resource via their execution. So we're going to take a minute and talk about that. If you look at those first three things, those are resources that anybody even familiar with using the web should have some understanding of. The web page itself is written in a language called HTML. It's just a file. You put it on your computer. Okay, there, it exists. It can be identified. It has a file name. We can identify that exact resource. An image is also stored in the file system somewhere. It has an actual file name. It can be identified. A video, same exact thing, stored in the file system. Give it a name. Well, what if you wanted to produce one of those things on demand? It wasn't stored in the file system, but instead you wanted to create a computer program that would create an HTML document on demand with whatever content you needed based on conditions at that moment. Or what if you wanted to figure out a specific image and modify that image on demand? You can write computer code that will do that. So the output of this code, these programs, is the other types of resources, documents, images, videos, etc. And like I said, we're going to return to that later on, but I want you to get the concept of a resource being either an identifiable resource like the things we think of, or a computer program that can make a resource. So it's a resource that can make a resource. Makes it kind of fun. All right, good. So I'm aware of the fact that there's a typo on this page, by the way, and I will fix that. Good. So one of the things that's out there in terms of how the internet and the web work is a thing called a URL. We've probably all heard that term. Many of you may have gotten to the point in the program where you've clearly covered what that is. But we're going to cover it because it relates to the overall subject, which is web application frameworks. A uniform resource locator is what it sounds like. It's a way to locate a resource. And it's uniform in that it's always formatted the same way. Good. So a URL is text that acts as a reference to a web resource. It points to a resource. They're commonly called addresses or web addresses, but that's the technical term, is URL. The URL specifies the location of the resource out on the internet and also a mechanism for retrieving that resource. Let's look at an example. It looks something like this, and you can see http://www.foobar.com/index.html. So let's break that down. Here, the resource we're concerned with is that actual web page called index.html. The mechanism for retrieval is the hypertext transfer protocol. That's how we're going to retrieve that. It needs to be formatted according to that protocol. And the location of that resource is on the web server for the site foobar.com. And here's a point. It's located in the root directory for the site. We'll come back to that a little bit later, but that entire thing, from the HTTP all the way to the HTML, that defines everything that's needed to find the needed resource and deliver it back to whoever requested it. So that's a URL. We're going to look at some examples here. A URL for an HTML document. You can see that it's the HTTP protocol, and it tells what server, foobar.com, and it tells you the name of the resource, example.html. Then you can look at an HTML document that's in a subfolder on the web server. Look at the difference there. Everything's the same, except that once it hits the server, www.foobar.com, it has to find another folder called subfolder. I got really creative in naming this. And inside that folder called subfolder, that's where you'll find the actual resource, example.html. It's just a text document titled example.html. Now you look at the idea of finding a resource that's an image. And you can see it's right there. Go to the web server, you'll find it right there in the root directory. It's called catpic.jpg because that is the actual purpose of the internet. I should have corrected the materials earlier. The internet exists to exchange cat pictures. Okay, that's not really true. All right, good. An example for a video. Same thing. What if you stored the whole movie Princess Bride right there in that website? You'd go to the website foobar.com and you'd find the actual file. It's an MP4 movie format. It's called Princess Bride. And finally, again, we're going to come back to this in detail later on, but just to show you kind of how it can be formatted, what if you actually want that uniform resource locator to point to a computer program? You would say foobar.com/getAllStudents. And getAllStudents refers to the name of the computer program, or part of the computer program, that's actually supposed to handle the action. and produce a resource once it's done working. And we're going to get to that stuff in detail later, but you see the concept here. If you go back to URL, it's a reference to a web resource. It shows what the resource is, how to retrieve it, and where it is. So all four of these examples show what the resource is, either the HTML document, the JPEG, the MP4, or a computer program, and it shows how to get it, where it is. Good. Now, a key part of that URL is a description of where exactly to find the resource on the web server. This component of the URL is called the path component, because the URL has a bunch of components in it. In one earlier example, we used foobar.com/subfolder/example.html. The path component is that text /subfolder/example.html. That is the path part of the whole thing. On the web server, the way this would look is there'd be one top-level folder for the website. Usually, that's called www or similar. That's the name of the website folder, right? Inside that folder, there'd be another one named subfolder. And inside that subfolder, you find the file we care about, the actual resource. Note that you don't need to specify the actual root level folder in the URL. In this example, www. You don't need to say that in your actual uniform resource locator. The server itself, the web server software is configured to point to that folder when you set up your site. So you don't need to say it. It's implied. And not knowing that makes this whole area confusing to people that are like new to technology. But that's why you don't have to say where it is. You've configured the web server software on where to point. It doesn't need that part. It just needs anything below that level of folder. Does that make sense? Any questions on that? Good. Now let's get into a fun part. And this is like some of the, you're going to get a, like this is also an overview on just web development itself. There's two types of requests in general that can be made of the web browser. Static requests and dynamic requests. A static request is for a resource. It's a request for a resource that is already stored on the server in the form needed to satisfy the request. Nothing about that resource needs to be changed. It can just be sent back, unmodified, with the HTTP response. These are things like images, videos, etc. You don't need to do anything in it. Just send the image, send the video. Doesn't need any modification. It's a static request. A dynamic request, on the other hand, and this is where we get paid lots of money as developers, it's a request where the requested resource needs some modification before being sent. Or even the resource needs to be created from scratch. This can be customized content on a web page, or even the entire page itself. We'll look at how that's done later on, but you can see there that that requires logic. It requires some knowledge of the state of things or the action to be performed, and it's dependent upon whatever the conditions are at that moment. That's what you use to create the resource. You can't just grab some static resource. Something about it needs to be customized. And we're the customizers. I don't know if that's a word or not. So, another function of this web server software. Notice at the top says web servers can map the path. Here we're talking about the software, either Apache or IIS, Internet Information Services. Web servers can map the path component of the URL based on whether that request needs a static resource or a dynamic resource. Static requests are just mapped to a local file system resource. There's that example again. The resource is the file 8example.html, and then it just, the web server maps straight to where that is in the local file structure on that physical computer, wherever it is. Dynamic requests, though, are mapped to a program name. I've already touched on this a little more. Here's where you get a bit more detail. The program that's referenced can be on the web server computer itself, or it can be on an external computer. Either way, you're going to point to a computer program or a part of a program, and that program is going to do work. And the output of that work, the result of the work, is a resource that can be shipped back to the browser. So let's look at this example. We have, foobar.com/getAllStudents. Here, the program name, or part of the program name, the name of the part of the program, would be called getAllStudents. As an example, you can tell from the name, it would execute computer code that gathers a list of all students. And then, this is the important part, it would format that data, the collection of the list of all the students. It would format that data in some structure that can be sent to the browser. Likely it would be an HTML table or some other HTML structure, but it's something that when it's sent back to the browser as part of the HTTP response, the browser can consume it and do something with it. And now you've created dynamic content. Like you might ask for get all students at 8 in the morning and then do it at 5, and they've added 3 students. That page is going to look different on the person's browser because it's based on the result of running the get all students code at the moment you ask it to be run. Good. Now that we have a clear understanding of the internet, the web, hypertext transfer protocol, user agents, web browsers, URLs, static versus dynamic requests, we can explore web applications themselves. Web applications are client-server computer programs where the browser handles the user interface and usually some computing, and the web server handles the implementation of business logic, and it's an interaction with persistent data stores. We're going to see some diagrams that make that a little more clear, but look at that for a moment. There's a few different factors. It's a web application, and you can see that the application, the computer program, actually lives in 2 different places. The computer program, part of it lives in the browser, because you need something to handle the user interface, and part of it lives down on the web server. The overall application is a thing, but you'll be doing development work in 2 different places. Let's look at this diagram. You can see the web browser at the top, and let's just follow one step at a time. The web browser requests a dynamic page. We don't much care about static pages because those are pretty simple. Just find them in the file structure. So the web browser requests a dynamic page. And step 2, the web server software finds that page and it gives it to a thing called an application server. That application server, that's where your custom computer code lives. That's where the get all students that I referred to a few minutes ago would live, is on that server. It might be right on that same machine. It might be an external machine. But that's where your computer code lives. So this third step is that application server scans that page, the HTML page, for instructions. And it looks through and says, oh, look, right here, I'm supposed to use this get all students thing, and I'm supposed to go access the database and find all the students as of right now. So the application server creates a query in step 4. It takes that query and it sends it to a database driver. A driver is just a specialized piece of computer code that acts as a bridge between 2 different things. The driver takes that query and executes it against the database. It says find all students where active equals true or whatever. The database then in step 6 creates that collection of results. It's called a record set. It's a set of all the records in the database that match the query. And it returns it to the driver. The driver sends it back up in step 8 to, in step 7, the driver sends it to the application server. And here, in application server, this is where your custom code that you would make as a software developer lives. The application server inserts that data, the record set data. It inserts that data into the page, the HTML page, and then passes that page back to the web server. Now, the web server has a resource that can be consumed by the browser. The browser can't consume what's produced in step 6. It doesn't know how to handle a record set result from a database. The browser only knows how to handle HTML. So in step 9, the web server has combined those 2 things into one finished page, and it sends it back to the browser renders it, and you see on your screen, wherever you are, this list of all of the students. Now there's a lot going on this page. We're not going to do a super deep dive, but I at least want to open up the floor to any questions about this, because it has some moving parts, and as we go into what a web application framework is, if there's any confusion on this, I want it cleared up. Well, doing pretty good? Good, excellent. All right, so to go back, web applications are client-server computer programs. The client here is the web browser. The server is the web server in combination with an application server. The browser handles the user interface and some computing. There's the browser handling the user interface because it got, in step 9, a finished web page, so it can handle the user interface. We'll get into some computing in detail later on. And finally, the web server handles the implementation of business logic. Let's look at that. On the application server thing, like step 3, application server scans the page for instructions. What if the request was to just get the details on student number 27, for example? That would be different business logic. That would be different code. So the application server is where the handles the implementation of business logic happens. And finally, interaction with persistent data stores. Sounds all fancy. It's a persistent data store. It's a database. And that web server is handling the interaction with the database. So this is how a web application works. Okay? Now, here's where we get into web application frameworks, what they're all about. There are actions that are common to almost all web applications. They're all going to have to map the requested uniform resource locators to whatever resource or code is needed to make a response. You can see that from what we've gone over. Almost always, a web application is going to want to allow you to sign up new users. It's going to want to let you authenticate users. Well, put in your password. I don't believe you are who you are, and you can't even look at the rest of this website until you prove who you are. It's going to want to do things like checking user authorization. This is where you control access to certain parts of the application. Like, for example, if someone is a customer, they're going to see certain things on Amazon.com. There's probably logins there for if you work at Amazon, and we don't get to see that stuff. That's user authorization, controlling access to certain parts of the application. Obviously, what's common to a lot of web applications is they're going to want to interact with databases. How are you going to get persistent data if you don't interact with the database? And most web applications are going to be involved in generating the final response that's sent to the browser, and it's a combination of pre-built HTML and dynamically created HTML, usually through the use of what are called templates. I'm going to go back to this diagram for a second. If you look at steps 6, 7, and 8, look at what it says here. Generating the final HTML response through a combination of pre-built HTML and dynamically created HTML. In step 3, an HTML page that has some code in it is given to the server. In step 9, we have replaced the little section that says code with actual HTML, dynamically created. And again, I'm hammering this point home. I know it's pretty straightforward and simple, but if you don't fully get that, it makes this whole thing kind of hard to understand. We take, on the left, on step 2, some pre-made HTML and placeholders for where we're going to eventually put more HTML. And then wrap all the way around the cycle to step 9. We replace the placeholder with what got created, the HTML that got created as a result of the code you made, the code that was executed in step 8. So look at that description again. One of the things that web applications deal with all the time is generating final HTML through a combination of pre-built HTML and dynamically created HTML. And it does that using templates. We'll look at that in a bit. So now, frameworks. As a reminder, a software framework is a pre-built piece of software. It provides generic functionality, and then it can be selectively changed by us. It can be selectively changed using additional code written by a developer. This makes it possible to create application-specific software in less time. Note that in this case, we're using the term application as the special use or purpose to which something is put. For example, you have an application of, I need software to handle running a school, or I need software to handle running a lumber factory. That's the application. You're going to take a framework, and it'll give you something out of the box, but you're going to customize it based on running a school, or based on running a mill. Good. Any questions on that? Just as frameworks as a general concept. Pre-built software, you get some generic functionality, and as a developer, you can grab it, tweak it, add to it, modify it, based on what you're trying to solve. We're all good on that? Good. Now, web application frameworks. They're frameworks for creating web applications. That's pretty much a duh moment. I want to build it in these blocks like this. Okay? So they're pre-built programs. They have generic functionality that's needed by most web applications. And then we, the developer, can obtain that web application framework in the form of the actual source code. You don't just get a working program and you don't get to look under the hood. You get the actual source code, the actual computer language code. And then you can selectively modify it, add to it, and you create an application-specific web application. And you do it in less time because you're not having to build what's given to you out of the box. So it's a very cool thing. There's many web applications available. Most of them are free. Some are proprietary and they cost money. They're available in nearly every popular language in use. C#, JavaScript, Python, PHP, Java, you name it. There's usually a web application framework or 50 available for that language. So now we get to what's in the box. Why it is that Eric even wanted to do this whole course, okay? Or this tech talk. While each web application framework is unique, they usually come with pre-built code that addresses the common actions we just talked about. Mapping requested URLs, signing up users, authenticating users, checking user authorization, interacting with databases, generating HTML using templates. Those are things that you're going to almost always need when you make a web application. So most web application frameworks come with that stuff out of the box. That's why we call it what's in the box. You don't have to build that. And not only that, you can look at it and tweak it to meet your needs. You can even delete it entirely and replace it with something of your own creation because you have a better way to do it. It's totally fine. Now, we need a little bit of discussion of the concept of front end and back end. In a web application, the elements that exist on the server, the web server, are called the back end. This would include static resources in the file structure, images, videos, HTML files. And it would also include the custom programs that are used to do things like prepare resources for dynamic requests, access databases, authenticate and authorize users, etc. So let's go back up for a second. Back end would be from web server down. Front end would be the web browser. The elements that exist in the browser are called the front end. This would include custom code that's used to present and run the user interface. It could take on some of the data processing tasks needed by the overall application. Now I want to stop for a second because I said earlier we're going to come back to that concept of the browser doing some of the computing. Let's say you wanted to look at an individual student who attended a school. There's two ways you could do it. Let's go back up to this diagram. You could have in the web browser a page where you click on the name of the individual student you want to see detail for. That generates a request in step one. Down on the web server, we eventually hit the database and find the detail for that individual student. And in step 9, we use that information. We've created a customized HTML document. It goes back to the browser, and all of a sudden on your screen, you see the information for student number 9 or 25, or whatever you chose. Or you could click on number 9, student number 9, whatever it is. But in the background, what actually occurs, if you set it up as a developer, is you ask the server for all students. Let's say there's 2,000 students. The response that's given back to the browser actually includes all students, but they're not all shown in the HTML. They're given as a separate collection, and the browser reaches into that, finds the data for the student requested, and it tweaks the web page and then presents it. So that again. The web browser's request, while it said I want data for student number 5 or whatever, the response actually includes all students, and the web browser extracts the data from that collection of all students for student number 5 and inserts only that into the web page. Why? Well, let's say a couple seconds later, you want to see the data for student number 25. Now when you click on it, the web browser doesn't need to get new data from the server. It's got all the data. It's got the collection of all the students. It can just simply access it. It's in memory on the user's computer, and it changes the interface to show the data for student number 25. You have now made the web browser do some of the computing, some of the work. And when you see definitions for web application on the internet, one of the most common things they say is, an application where the browser is used to do some of the computing. And that's what we're talking about. So let's go back down here. Front end and back end, right? The elements that exist in the browser are called front end. This would include custom code that's used to present and run the user interface, take on some of the data processing tasks needed by the overall application, and other UI tasks. And that's how that works. This is part of why, as a software developer, you're learning the basic principles of creating a computer program, but the place you put that computer program can shift. Good. So frameworks exist that cover just the front end, just the back end, and both combined. Usually, there's front end only and combined. You can also mix and match these things and do real hybrid things, because remember, it's just pre-made code. You can grab it and try to do whatever you want to with it. So you'll see various combinations out there. So here's some popular web application frameworks. Front-end frameworks, and they all use JavaScript as a language to do the actual coding in. AngularJS, React, Vue, and Ember. Hopefully you guys have heard of some or all of these names so far. But these are frameworks, pre-built code that you get the source code to that lets you make the front end. It lets you control the user interface. It lets you control some of the computing. Like, that's where you would write the code to hold on to the collection of all students that I referred to earlier and extract only the indicated one and insert an HTML for that in a page. You write that in JavaScript in that framework. Good. Here's some frameworks that cover both the front and the back end. The one we're going to go into in detail here in a moment, ASP.NET MVC. And the language you use for MVC is either C# or Visual Basic. Frankly, any of the languages that .NET will support, but most people use C#. There's Express. You use JavaScript to write your code there. Django, you use Python. Rails, it's also called Ruby on Rails because it uses a computer language called Ruby. It's a web application framework. Covers the front end and the back end. And then Spring, which uses the computer language Java. So there's some examples of these. Now we're going to have fun. We're getting to where we're headed at the game. ASP.NET MVC. We're going to explore a typical web application framework using MVC from Microsoft. This web application framework, first of all, it uses a way of organizing your code called Model View Controller, hence the name MVC. Okay? For those of you doing the C# portion of our training, you're going to hit that at that point. And frankly, people doing Python will also hit it because MVC is used in Django, which is a web application framework. So these concepts you're going to cover here cover both. We're just going to use ASP.NET MVC just to give you an illustration. Let's talk about MVC though. MVC basics. MVC is actually a design pattern. This is a way of organizing the various elements of a computer program and the actual code that creates and controls those elements in a specific pattern. And here's the point. Any given pattern was created with a purpose in mind. And there's a purpose in mind behind MVC. I'll explain it in just a second. But first, let's just cover what MVC does. MVC divides your application into three basic parts, each with its own concern. And what we mean by concern is the code in a given part of the application is concerned with a specific thing. The three parts are model, view, and controller. Each one is concerned with a specific thing that the overall application needs. So I said that a pattern was created with a purpose in mind. The purpose here is separation of concerns. So that later on, when you go to modify your application, if you're changing something in one area, it usually requires little to no changes in another area because the change you're making concerns only one thing. Good. That's a high-level view. You're going to dive into that much greater depth later on in your training. But let's cover a little bit. So a model. A model represents the state of a particular aspect of the application. That's really abstract. What is it? It's basically, what does X look like right now? An example. A user would be inactive or inactive. Right? A student would have a GPA of 3.52. An email would be read or unread. Each of the elements there that are in italics represents a specific or particular state of a thing. So the model is a representation of a thing the computer program cares about and what its state is right now. Good. So the model part of an MVC application will be where is state data obtained. In other words, that's what the model part is concerned with. It's concerned with, can I get state data for a specific object or collection of objects, please? Thank you very much. Now, a view. A view is a set of code that takes in needed information and then renders a user interface to display that information. What would an example be? You would want maybe a list of all students, or a calendar showing appointments, or a form that's used to accept information from the new user. And this is where to come back to what we talked about a few minutes ago. Most views in MVC frameworks use templates. These are files that are made up of two things: pre-made HTML and placeholders for the dynamic data that's going to be inserted. These are templates, and we've talked about this earlier in the presentation. Okay, so there's a view. Again, the view area of your code, or of your application, is concerned with user interface. Finally, a controller. This is the captain of the ship, this is the traffic cop, this is the person who runs everything. A controller is computer code that handles interactions, updates the model to reflect changes in state, and then passes information to the view. So notice the controller is what handles model and view. It gets or changes model state and then passes information to the view. This is where you put business logic. This is where you put if, then, else, conditional kind of stuff. So what really is this computer code in a controller? They are methods or functions or whatever you're going to call them. It's code that can accept data, perform some computing task, and give back data. Here's an example, one we've been talking about all through this presentation. Get all students. The two little open and closed parentheses on it indicate that it's a function or a method. It's a piece of code meant to take in some data, process, and then spit out some data. So what does it do? Well, it queries the database for all active students, puts them in a list, formatted for the view that will render the list. So let's look at this description right above. Controller is computer code that handles interactions. Well, conceivably, you clicked on Get All Students or View All Students, a button on your web page. The controller captures that. And we're going to see this in practice in a moment. The controller captures that interaction. And then it obtains the list of model data. How? It goes to the database and says, yo, give me a list of all the active students at this exact moment. Thank you very much. It takes that and formats them in a format that the view can actually have them. What format is that? HTML of some sort. Because all the view is going to do is go, oh, you give me this list of students? I've got a placeholder here that says, please replace this placeholder with an HTML thing. Boom, I put it right there. This list of students. Good, so model view controller. Now we get to look at an actual MVC application. Before we dive into that, are there any questions on that right now? Okay, you're going to see those three things in action. So now we get to pop out of this and go over to Visual Studio. All right, so we're going to actually see what is included in the web application framework called MVC, ASP.NET MVC, right? And it's going to give you a bunch of stuff out of the box. So you literally just go to File, New, Project, and Web, and we're going to make an ASP.NET web application. Call it Demo 1. Good, nice name. And we'll go down here and we'll click OK. Now, there's a lot of different options. I'm not going to go through all the different options here. It's defaulting to MVC. We're going to choose MVC. But we also want to explore the fact that a web application framework can give you code to control authentication. So right now it says no authentication. I'm going to say no. I would actually like to have individual user accounts for my application. That little click that I did right there is going to add about 10,000 lines of code that I don't have to write. And they all work right out of the box. It's kind of nice. So I'm done there, and I just click OK. And now, in the space of seconds, I get a working computer program. I get a working web application with the front end and the back end all working out of the box. Good, so we're going to explore this, but I want to show you a few of the things we referred to earlier in the slideshow. this computer program that I'm about to run needs a web server. It's got a browser. I got a browser on here. It's Chrome. You can see it down here. I don't need a browser, but I need a web server. Remember I said that Internet Information Services is installed on any Windows server. Any Windows operating system, right? That's true, but there's also a really small version of it that doesn't take very long to start up that we use just for development. It's called IIS Express. So look at the two things on that button, or three things. The green means, please turn my computer program into executable code and run it. The IIS Express says, this computer program happens to be a web application. It needs a web server. Can you please use IIS Express? And then it also says, it's a web application. It needs a browser. Can you use Google Chrome? Notice that I could change things there. I could actually use, if I wanted to, if I was forced to, Internet Explorer. But no one's got a gun to my head, so I'm not going to use Internet Explorer. I could, in fact, use the full-blown version of IIS that happens to exist on this computer. I'm not going to. But the point is that three of the things that we talked about, just in the generic concept of web application frameworks, are right here in this integrated development environment. Turn your source, the green is turn your source code into executable machine language that'll run. Put some of that code on an actual web server, and then start up a browser, which might actually have to receive some code too. And so when I click on this, all those things go into action. Everything gets, all my code gets turned into executables in ones and zeros of machine language. I spin up an actual web server called IIS Express, and the browser turns on in a separate window and hits that web server. And you're going to see the output here in a second. There's the home page of my web application. Now, if we go back here to Visual Studio, let's kill this. See that? We're going to explore this file structure of our web application in detail in just a moment. We're going to call to mind a couple of things. We have a models folder, we have a views folder, and we have a controllers folder. In each of those folders is actual code. This is a C# file right here. Look at the C# on the left. I have separated the code that's concerned with controlling the application into a folder all by itself, just called controllers. If I need to change something related to controlling the application, I go right here, and I don't have to do anything usually with, the views. And the views have a bunch of files in them as well. They're organized according to how you structure your application, but look, here is an actual file. This is a view file. We're going to explore this in a little bit of detail later, but notice that this is a combination of HTML, look at line 7, look at lines 4 and 5. That's HTML. But look at line 4. That's not just HTML. That's got some weirdness going on. That weirdness that says @viewbag.title is code. That's computer code. If we go back for a second, and do the present, and we go up here, this diagram, look at step 2. And look at that tiny little image. It says HTML, code, and HTML. That's exactly what we're looking at right here. There's code. Everything after that highlighted yellow ampersand is code that the web server is capable of understanding, processing, and generating HTML from. In this case, it generates the title of that web page. And in line 5, it generates a message. You can set the title. You can set the message. You can customize them. And instead of them being fixed permanently and making this a static page, they are dynamic. You can control them with code. Good. So That's models. Oh, so that's views, right? Now let's look at models. In models, let's look at this model right here. You can see from looking at this model right here on lines 49 and 50. Look, there's a lot of C# code here. I don't want to confuse you. You know, some of these terms can be kind of odd. But this is a model related to if someone wants to log in, what do you need? You need an email. You need a password, right? So if you're going to have someone log in, that email can be whatever they typed in. And the password is whatever they typed in. And now you can go down and reach inside the database, get the data for that email, match it up against the password, and if it doesn't match, sorry, you're not allowed in. All that code was pre-generated for me, guys. I didn't have to create any of that. It's wonderful. It's so much out of the box. Good. So now let's get back. We've got this running application right here, okay? So if we go back to the concept of what we would want in a framework for a web application, it's things like, creating a new user. That's common to almost any kind of web application you're going to make. Why reinvent the wheel? Well, you don't have to. I'm going to create a user account by clicking on register. And I'm going to create an email, enter in my desired password, repeat it, and I'm going to click register. It's actually creating a database record for me. And it happened pretty darn fast. Look at that. It knows that I'm in. Now, I want you to check something out. That content you're looking at on the screen, hello, foo@bar.com, that was dynamically generated based on who it is that's logged in. And it was only able to get that data by accessing the database and getting model data for the current user. If I do this, log off, and I'm going to register. Let's do one under my email address. Click register. Look at that. Hello, Erik.d.gross. Now that dynamically created HTML is presented in the browser for me. And that brings together all of the things we were talking about in the earlier parts of this. Now again, depending upon where you are in your training, most of that was review. The point I want to make here is that you get all of that out of the box. You don't have to set up anything on that. I didn't have to set up any code related to creating a new user or authenticating a new user. Because look, I can log off, and if I want to log back in, I can log back in as foo@bar.com. And I can put in the password, click login, it checks the database, it authenticates me, then click. And look, I'm in. Hello, foo@bar.com. I didn't have to build any of that code. How nice is that? Now I can tweak the heck out of it if I want to. And you can see the code. It's all in here. In fact, let's look at what happens when someone tries to log in. I'm going to go to login right here, okay? And we're going to bring together everything we were talking about earlier. I'm going to log in as Erik.d.gross. Type in my password. All right, now, we're going to break into the application. Look at this URL. Notice that it says account and then it says login. When we talked earlier about the idea that web application framework is interested in mapping incoming HTTP requests to whatever will handle that request, that's what we're going to see here. There's going to be an actual computer code, a method called login. That the request, when we click this login, it will send the data I just put into the browser down to the server, and the web application framework, MVC, ASP.NET MVC, will know, because of this URL right here, to map that to a specific actual computer code. I'll show you where to find it. Notice how it says account and login. Go back here. What element of this computer program is it that handles user interactions? Anybody remember? What's the traffic cop? Controller, exactly. So let's look at the controllers. Go back to the browser and it says account. Ooh, let's look at the account controller. We are now looking at all the code for the account controller. Then it says login. There's going to be a method in here called login. Click on here, it shows me all the methods. There's a lot of them. Come on. There's login. And it takes me to it. Looky there. A method, a part of a computer program, to refer back to the beginning of this presentation, a part of a computer program, a named part that's in the URL that my web application framework is going to map to. So if I put a breakpoint right here and go back and click login, I am at that exact piece of computer code. And I can even see on this what I typed in the browser. I have successfully passed the information typed into the user's browser down onto the server, because this code right here, login, it's down on the web server. It captured my username, my password. And then I can literally step through one piece at a time and watch what it does. What we care about is what's the result of whether or not I actually typed in the right password. So let's watch. Right now, we're going to bring together everything that we talked about earlier in the presentation, including how MVC works. Because the view is what created that user interface. And HTTP request was triggered by my clicking on the button. I clicked on the login button. It triggered an HTTP request, which was captured by my web application framework down on the server and routed to an exact piece of code in the controller. That controller received all that data, and I can step through this code and watch. What I'm doing right here is I'm actually going to check the database, the model data, to see whether or not I actually am allowed to access this website. And if I click one more time, and then roll over result, it says success, because I didn't type my password right. Now watch. It let me in. Let me log off. Log back in. And let me type it wrong. Again, that piece of the program captured that action. I'm going to step through. I'm going to check the model data. I'm going to reach into the database and get the actual password, and I'm going to compare it to what I wrote, what I typed in. Now, what did I type in? I don't think 4 or 5 F's is actually my password. So when I click, boom, my result is failure. And now look, the user interface is different. It was dynamically created based on the computer code you wrote. So I'm going to step back to the high level here, okay? And then I'll give you the data that we promised about analyzing any particular web application framework. Okay? The high level data here is that we have in place here a web application, which means there's code that controls the front end, there's code that controls the back end. We have at work here the HTTP request response cycle, which means the request can come into a web server, and you can have a combination of static and dynamic things that happen. And at the end of the day, HTML gets sent back to the browser and rendered. All these things are working. But now let's get back to how to examine your web application framework for what's in it. go ahead and stop it running. It's as simple as this. You get a new web application framework, and you're not sure what it is. And you can literally Google, because Google is awesome, and say, let's find this. We know that we need to handle routing or mapping of requests. So we can say mapping URL requests in ASP.NET MVC. Or insert whatever web application framework you're trying to study, right? Because you know that that's probably something that's needed, right? Routing module is responsible for mapping incoming browser requests. The route is just a URL pattern mapped to a handler. It's going to show you exactly how we do that in this web application framework. So if I did this in Django, Django Unchained is not a web application framework. Ooh, it looks like it's called a dispatcher. Module is pure Python code, a mapping between URL path to Python functions. Boom! Everything we talked about in the earlier parts of this presentation is there. And because you understand, hopefully, the overall concept of how that system works, you go, oh, right there is what's going to show me, if I actually install the web application framework called Django, how to control or follow along with mapping an incoming URL request to where exactly in the code I'm going to find the actual code I need to change. Why is that valuable? Okay, let's go back to the very, very earlier part of your training. One of the earliest things we go over is the 5 basic elements of any computer program. And if you recall, they are an entrance point, variables, control and branching statements, subprograms, and exit point. Of those, when you get on a new job, the most valuable, in my experience, is knowing an entrance point to an application. If you can find any point close to when that thing spins up, you can stop the execution of the computer program and step through, like I did earlier, you're doing really well. So if you find out mapping, and you spin this thing up and you can tell from the URL in your browser where in the code on the server it's all going to get mapped to, you can go right there, put a breakpoint, and boom, you broke it into a computer application. And now you've got a snowball's chance in heck to analyze it and figure out what it's doing. Because here's the point. We just looked at a pristine, clean, gorgeous version of an MVC application. I have customized literally nothing about this code. When you get an actual MVC application, the degree of customization is going to be insane. And you're going to be looking at this, and you're going to be looking at the file structure, for example, and there's going to be sometimes no less than 20 or 30 or 40 other folders. You're like, what is this folder called Chicken Little or whatever it is? You have no idea what it is. But what you do know is the basics of a web application framework, how to Google the different elements of it, how to map, figure out how to map where your requests are mapped to in your code, and you can break into the application and start to sort the important elements of it from, well, that's just something customized for this instance. Good. So another thing, you know that user authentication, like which section of a computer program I'm allowed into, is something that a web application framework is probably going to implement. So you can actually type user authentication in ASP.NET MVC. User authentication. Okay, good. Let's see what it says. Verifying the identity of the user. Might need to present your application only to the authenticated users. And it shows you. And you oh, good. You can literally just go through this tutorial and it'll show you how do I control this. But the point is, if you grasp some of the fundamentals here, you know there are 5 or 6 or 7 things that almost every web application framework is going to have pre-built code to help you with. And you search for that, and boom, you open up the world of how to modify it to your heart's content to fit the actual business need. Or scrap the whole thing without causing damage and replace it with one of your own. Good. So that's my tour of web application frameworks, why they even exist, the help they are, how to kind of think with the operation, and identifying how a new one works. Any questions? Okay, good. Awesome. That's it. Thank you.